All right, everyone. I am here with Huiji Gao. Huiji is a senior engineering manager for ML and AI at LinkedIn. Huiji, welcome to the TWiML AI podcast.
Thank you. It's my pleasure to be here.
Hey, I'm really looking forward to digging into our conversation. We're going to talk quite a bit about NLP and some of the software and models that your team is building. But before we do that, I'd love to have you jump in and share a little bit about your background and how you came to work in ML.
Yeah, thank you. Yeah, I have always been interested in this machine learning and their applications back to my college. I remember kind of like 15 years ago, I was in the studying the information retrieval, and I was using CRF for the conditional random field model to develop named entity recognition. Then in my PhD study, I was in this machine learning and data mining lab, studying the recommender systems. So in my major research topic at that time is how to develop advanced recommender system with spatial, temporal, social, and content information. And in addition to several papers and also a book called Mining Human Mobility in Location-Based Social Networks, we also developed several algorithms to help do better recommendation for the POI for locations. During my study, I had an internship at LinkedIn, and at that time I was working on how to model users' interests in companies to help on job recommendation.
Hmm.
And after that, after my graduation, I joined LinkedIn as a full-time. That is about 6 years ago. I
Awesome.
started, I started my journey in ads, in the ads domain, with ads CTR prediction and targeting problems. I was quite amazed by the LinkedIn's rich data set. We have a large amount of members with their profiles, and the members, they connect to other members. They also consume content, and they also say search or looking at learning courses. While different members, they have different lures. For example, a member could be a job seeker looking for jobs, could be a recruiter looking for good candidates, and could be a salesman, and the member could also be a content generator or consumer. So with all that say comprehensive data set at LinkedIn, that was also my first time to get into this large scale distributed training area to learn how to train a model with distributed training and how to process the data. About 2 years after I stayed in the ads domain, I moved to search problems. So that time I was developing ranking algorithms for people recommendation, for people search. So the product is called People Search. About 3 years ago, I started to manage a team called the AI Algorithm Foundation Team. And this team is to develop advanced AI technologies on natural language processing, ranking, and personalization to power all the LinkedIn search and recommender systems. In addition to the product impact we had so far, we have also open sourced a set of technologies. One of the most recently released open source packages called DText, DEText. It is an intelligent text understanding framework for our engineers to easily generate models for ranking, classification, and language generation. So it has also received several stars on GitHub. So far, we have about 1,000 stars. We also have published several papers on related work, and one of them got the Best Paper Award last year in CIKM.
Nice. Nice.
Thank you.
So let's maybe dig into DText and start with what are the main motivations for the tool? What were you trying to accomplish when you started down that road?
Yes. I think we started to think about this idea 2.5 years ago. As you know, that LinkedIn, we have rich data sets in all kinds of search and recommender systems with respect to different entities users are interested in. For example, for people, we have people search, people recommendation. It's called PYMK, people you may know. And for jobs, we have a job search, and the job recommendation is called Jingdi, jobs you may be interested in. And for content, we have content search, and say content recommendation is like feed and ads. We also have other entities like skills, like groups. Now, all these informations, it is kind of like represented by a large amount of text data. And from the member side, we also have member profiles and also members' interest, members' past behavior by interacting with this text data. So how to understand this data is crucial for us to improve all this kind of search recommender system at LinkedIn. And at that time, I would say majority of the system is leveraging the NLP in terms of, say, keyword match or skip gram embedding that is not considering a lot of contextual information among words when we generate embedding. So whereas there are a large amount of applications in search recommendation, so we can name a few. For example, ranking is one, and understanding users' intent classification, sentiment analysis, spam detection, autocomplete, machine translation. So all these problems, they will need to be they can be powered and to get better performance by NLP. So we are thinking about build a, say, end-to-end framework that can target it on two goals. First is to provide a better semantic understanding with advanced embedding technology. Second is to provide a better framework that can leverage this embedding technology for all kinds of applications, as I mentioned before. So that is DText. It is a offline framework to help our engineers train offline models with this NLP technology for ranking classification and language generation.
Got it. Got it. And so what was the landscape for using embeddings for these kinds of ranking problems at LinkedIn before DText?
Yes, before DText, the way is we started with keyword matching. Like, let me give you an example is if you search for Huiji software engineer LinkedIn, this is a query. And we look at documents that contains the keyword Huiji or software engineer or LinkedIn. But you see, sometimes there are synonyms. For example, software engineer and software developer. They have the similar meaning. If we rely on the keyword match, then the job with software developer will not return.
Won't show up.
Yeah. So sometimes this is the early stage. And then we start to look at different embedding technologies. For example, skipgram, that is also one of the state-of-the-art embedding technologies. And I would say the cause of this kind of embedding technology, it cannot better capture the context among words. Like context between software engineer and LinkedIn, between Huiji and software engineer. So there are a lot of new technologies coming out in the past few years, like how to use CN for embedding and how to use STM for embedding. And I would say about 2 years ago, the most of the promising technology is BERT. It can help to enhance this kind of contextual modeling among any two words in an input text sentence, and then generate a better embedding to represent this sentence. So that is our kind of target when we develop a DText, and pretty much also captured the journey when we started this text modeling.
Mm-hmm. And so is DText based on BERT? What's the underlying model and the relationship between the framework and the model?
Yes. So DText is based on BERT, and it can also extend to support CNN and LSTM. Yeah, there are kind of two ways to use this kind of BERT embeddings or other CNN embeddings. One way is we extract this embedding as the first step, and then we use this embedding as features, put them into our current ranking framework. It could be, say, a tree model or a linear model like a logistic regression model. This kind of two-stage modeling, as you can see, it may lose some information. because the embedding was generated by a different algorithm without the context of the other information that will be used in the ranking model. Yeah, so DText is a model that can help generate this kind of ranking and classification model using through an end-to-end process. We start from the raw text data, get the embedding with BERT or CNN, STM, and then together with other existing handcrafted features, eventually they share the same loss function and their parameters updated simultaneously.
Mm-hmm.
Yeah.
And so talk a little bit about the kind of broader context for using DText. Does it, you mentioned you did some work on distributed systems earlier at LinkedIn. Are you using it in that kind of distributed context, or is it used as a standalone type of system?
Yes, it is in a distributed context. And actually, in order to enable that, to ensure we have a good efficiency of training, we actually did a lot of work to power that. So one of the challenges, as you can imagine, that I'm just using BERT as an example. You can imagine that because of the model of this contextual information among words, it itself takes a lot of time to inference. So, so one way we have looked at is to start with a more flexible BERT structure. For example, the original BERT released by Google has a 12 layers version and a 24 layers version. And there are some gap by using this model directly at LinkedIn. First is, with this large number of layers, the inference and training time itself would be quite time consuming. And some of them cannot meet our product request. Second is
when you say can't meet your product requirements, is that from a latency and inference time?
from latency, right? Yeah. From latency, yeah, and also from the offline training. Say when we want to periodically retrain the model, then the retrain itself needs to meet certain requirements. If we want to retrain it every 4 hours, but the training itself takes 40 hours, then this cannot meet.
Okay.
Yeah. So this is the first gap. The second gap is from the model itself, because the original model is trained with the Wikipedia data. And as we know that LinkedIn, we have very, say, domain-specific taxonomy. So the skills, titles, and also users' experience are company names. And how can we incorporate this information into the BERT model is a challenge. So in the end, we decided to train a BERT model using LinkedIn data. So we call this BERT model as LibERT. There are several benefits. One is, as we mentioned, it has better semantic representation on LinkedIn data. And the second is because we are training it from scratch, so we are able to, say, start with a more flexible structure, like 3 layers, or 6 layers, or starting with 256 lengths of embedding size. Yeah, that is indeed what we do. And the one in our production, I think currently used is a 6-layer LibERT model. Now, this can help us to significantly shorten our time by pre-training such language model, and also shorten the time for online inference.
So sounds like the general idea there is that, because you've got the resources to do it and a very significant data set, you're giving up the advantage of externally pre-trained BERT model and maybe doing some fine tuning and just training from scratch on a simplified model. And you found that gives you better results.
That's right. Yeah.
How do you, when you think about the attempts trying to get BERT to work, standard BERT to work versus LibERT, how do you compare the two? What performance metrics did you use when you were evaluating the new approach?
Yeah, that actually refers to another challenge of using BERT in DText. So in the beginning, the model performance is not good comparing to, say, other state-of-art ranking model using CNN or
Mm.
ASTM. Yeah.
Mhm.
The reason is in the beginning, what we realized is the way to do BERT fine tuning in ranking tasks. So, like what we mentioned before, is about how to pre-train a model, pre-train a BERT model with
Yeah.
linked data. After we pre-train the model, the typical way to use the BERT model is to fine-tune it in a specific task. And in this current scenario, it is how to better used in ranking task. But the
Mhm.
challenge at that time is in the original Google's, so in original BERT's paper, it lists several ways to use BERT model for like ranking and the name entity recognition. And the way to use BERT model for ranking is we need to concatenate the information from the member side and the document side together as one sentence. So
Mhm.
imagine I'm a user. I'm here to search for something. I have a query here. And in order to use BERT, we will need to concatenate this query information with every document information together. Then we send it to BERT, and to get a genetic representation for the whole sentence, then we decide how to rank this specific document. But you see, this becomes a big challenge for online latency, because we are not able to do a lot of pre-computing until we see a query. And only after we see a query, we will have to start concatenate this query with every document candidate, and then do the scoring, which is usually beyond the seconds or even tens of seconds. That is not acceptable by the production.
Right. And
Yeah,
the reason why this comes about is because you have you have to include the user, and you have so many users that you can't pre-compute
that's
all of
right.
that.
That's right. Yeah, yeah. Because of this strong coupling with user typed information, this forbid us to pre-compute a lot of information, which
Mhm.
we used to be able to do before we using BERT model. And
Mhm.
of course, the reason of doing this for ranking model is because the reason of coupling them together is because BERT is good at capturing the contextual information among different words. By concatenating them together, it does pose a good opportunity to capture the contextual information, but it makes it a challenge to get into product. So what we do is we tried a lot of different framework settings, and eventually we found this way. That is currently the current way used in DText. We split the information from member side and query side to different input fields. And with these input fields, we still send them to BERT to get the embeddings. However, we concatenate them together after we get the embedding. Actually, we cross them together after we get the embedding. So to generate the similarities among these different fields as based on the embedding extracted from the BERT. And from this way, we kind of like break the context earlier, but then model this context later after we get the embedding. And there's a risk because it is uncertain that whether use this framework can still capture the original content information that BERT is supposed to capture. So we did several experiments, and eventually we found that this way, the way we are using in DText, indeed, it is able to do so.
Now, can you go through that again? What specifically are you doing that's different from the standard BERT of concatenating the
Yes,
user document?
yes. So in the standard BERT, it is concatenating the raw text and then getting the embedding, then for ranking.
Yep.
Yeah, and in DText, we get the embedding from each text field before concatenating them. And
You
then
mean the search query and
okay,
the
and the
document as well?
documents.
Yep.
Yes. And then we compute the similarities among these different embeddings. So this is kind of like to learn their contextual coupling after we get the embedding. And then these similarities becomes new features that we can use later for the ranking model.
Hmm. And so does that allow you to do more pre-computation on the document side?
Exactly, exactly. In this case, as you can see, when we compute the BERT embedding, it is no longer based on the concatenated sentence.
Right.
It is based on each individual field. So the query side is computed separately. Member side is also separately. And then after the model is trained, we can pre-compute these member embeddings and then store them in certain store that can be fetched online. While query side, because it is short, so we are able to do the real-time inference with BERT. That is doable. And in this case, as you can imagine, when online a user comes and a user search with a query, we use this model to do real-time inference for this query's BERT embedding. And then we fetch the member embedding from the pre-computed store. And after that, we do the inference for ranking. Yeah.
So, end of the day, what kind of performance properties does this have?
Yeah.
Presumably it met your goal, but what exactly
That's right.
compared to what you saw with the original BERT?
Yeah. So our metrics is based on the different product applications. For example, when we evaluate the people search and the job search, we look at the metrics called NDCG. That is kind of like a typical evaluation metrics for search ranking. And when we when we use DText for feed and ads, we look at the CTR, AUC. So that is kind of like look at how much likely a user would click on a specific content given the impression. This is for offline. And for online, we also have different metrics for different products. For example, search-wise, we have search sessions and ads, that is revenue, and also online CTR. Example as I can share is when we use this model for people search, we observed a significant lift on the online searching success rate.
Yeah, I was also interested in the inference performance in terms of time. How did that compare from before and after?
Yeah, good point. The answer is I'm not able to provide this result because the baseline model is not able to ship into product due to the latency concern. Yeah, it is not doable. Yeah, so
you didn't even get far enough with the baseline model to
yeah. Yeah. For the current model, the online latency is within 20 milliseconds.
Okay.
Yeah. Original one, as I can imagine, it would be more than 10 seconds something.
Are there other ways that you have optimized it besides from the kind of high-level architecture?
Yes. We optimized on the product stack. So even with this kind of DText structure, even with this decoupling of the user side and the document side, we still encounter challenges about online scoring because of the large amount of candidates. So like for search systems, some of the search systems, they have hundreds of thousands of candidates to rank at real time. So in that case, we actually set up a few ranking stages. So for example, we have first pass ranker, which is using a very simple model to quickly filter out those definitely irrelevant documents. And then we use DText to do a more fine-grained ranking based on this, say, reasonable size of candidates.
And is the pre-filtering model, is that also a learned model?
It is a learned model. Yeah, it is. There are several options to use this model. For example, a tree model with simple structure, maybe just a few layers, and a logistic regression model. And the feature set could be very small, a few tens to hundreds, because the purpose is not to get a better ranking at this stage. It is mainly to filter out those irrelevant documents. So the next stage of ranking by DText can be launched without latency concern.
And so, what do the features look like for that pre-model?
Oh, yeah. Those features could be, for example, users region and the matching between the query and the or documents in terms of keyword match.
Mhm,
And this could also be the user some context information. For example, whether this user is searching the query at a certain time point, day of the week, hour of the day. Yeah, and the user's social connections. These are the information can be used. I'm just giving you some examples. Yeah.
mhm, mhm. So the first one that you mentioned is, very intuitive. You might want to, if the user's issuing a query in English, you might want to limit your search to English. And it sounds like this pre-model or this pre-filter is one of the mechanisms that you might use to do something like that.
Exactly. Yes.
And so tell us a little bit about maybe in past conversations I've talked with folks at LinkedIn, and the idea of graphical models comes up a lot in the way you build machine learning on the user graph and content. Does In what ways do these models, DText and Liebert, do they kind of interoperate, or are they related to being used in a graphical context?
Yeah. Currently, we are still exploring this direction,
Okay.
and DText is not using graphical embedding technology, but we do see the motivation of using graphical embedding together with text information to generate better embeddings. So let me give you an example. Uh, mm, the way we are looking at it is we can leverage users' interactions, their actions to certain content, click, like, share, and their social connection to different people. These are kind of like linking information. If you look at this graph,
Hmm.
and there are also node information, that is node properties. For example, when a user is clicking on another job post, and in addition to this linking information that can be used for graphic neural network modeling, if you also look at the node information from member, from the job post, this text information, and we do a joint modeling, then you can imagine in the end, we can generate a more comprehensive embeddings with this huge economic graph at LinkedIn. And the benefit of doing so is maybe in the future, we can eliminate certain filters by doing this kind of modeling together. For example, maybe in the retrieval side, we want to first filter out by the social connections. And then we do a ranking within this specific range of social connections. But if we have this graphic neural embedding with the text information, then we can have better representation. We may not no longer need this kind of filters in the beginning. So this is some idea still at the early stage to discuss. Yeah, but we do have some future plan to improve DText on that direction.
Yeah. Along the same lines, is DText, is it tightly coupled to BERT, or could you swap in another type of model, language model, to replace BERT?
You can, yeah, it can. You can switch the BERT model to other models like CNN, like Libert, like ASTM, and even for the BERT model itself, it is quite compatible to different kinds of BERT model, like Google's BERT model, Microsoft Tuning model, and the Robota model developed by Facebook. These are all different options that we offer to the clients.
Hmm. And with clients using those different models, is there any intuition you could share around, when they tend to use one versus the other? How do they compare relative to one another for your use cases?
Yeah, yeah. So far, all this exploration is actually more on the towards the offline side. For production wise, because as we do have this product constraint, so far the Libert model is still the first choice because of the flexible structure, 3 layers, six
Mhm.
layers,
Yeah.
and performance wise, I would say for a fair comparison, it may be very hard because the Libert is trained on LinkedIn data, and the other BERT model is trained on other domain-specific data. So we do observe that offline-wise, there are some performance difference, but it's sometimes very hard to draw a conclusion under this kind of setup to see like which model is better or not.
Mm-hmm.
Yeah.
Are there other models that you hope to customize in the way that you have with BERT and LeBERT?
Yes, we do. Yeah, we do. So because these models, they are also open sourced, it actually provides us opportunity to customize them further and compare with LeBERT and provide to our other LinkedIn clients. Yeah,
Mm-hmm.
as long as we have enough, say, engineering resource to support that.
Got it. Talk a little bit about the practical use of this from an engineer's perspective. Is this a library that they include in their notebooks and use in that way? Is it a online system that they're querying? What's the deployment model?
Yeah, there are two ways to use this. One is, as you mentioned, use it as a Jupyter notebook. And this way is more about earlier offline analysis and a quick explore of the results. So in that way, users can just say organize their training data set into a format that is required by DText. And in DText, we have a lot of parameters, but we also have this, say, starters parameter. That's the default parameter we already set up for most of the use cases. And we also have advanced parameters that can used for like by machine learning experts to better tune the performance. Yeah. So users can use them in the Jupyter notebook or in our offline training stack. So this can be used, say, as a library. You can incorporate it into your current tech stack and adding it as like as a workflow with this parameter setup. Then you run and get the model.
Mm-hmm.
Yeah.
And can you give us a sense for how often are users kind of using off-the-shelf basic parameters versus the other end of the spectrum, folks that may want to tweak the advanced parameters or even fine tune? I'm trying to get a sense for, with these types of models and your type of use case, do you find that everybody has to fine tune quite a bit because they need to do that to get the level of performance that's acceptable, or is it good enough off the shelf for a lot of people?
Yeah, that's a very good question here. So the tune first of all, I think fine tuning itself takes some effort.
Hmm.
By dealing with these parameters, it will require some of the expertise from our AI engineers.
Yeah.
But it also depends on the application. As we observe, for example, in some of the search applications, they can share similar patterns on tuning these parameters. And
Hmm.
some of the other applications, say like ads, feed, they have very large scale data and also very sparse features. Then the tuning may take some time. That's why our current our current effort is to develop an advanced optimizer for DText. And this can also be generically used by other deep learning algorithms. So this optimizer is trying to help our AI engineers find a better setting of those key parameters, say batch size, learning rate, and model selection iterations. And we want to make it like more optimal and make the model less sensitive to those parameters in terms of the user's usage.
Hmm.
And that is already ongoing. And we actually see some quite promising results by using this advanced optimizer. Yeah, one example as I can share is we are exploring the layer-wise optimizer for
Okay.
BERT. Yeah.
And so is the optimizer, what can you say about the general approach to optimization? Is it, along the lines of a Bayesian optimization, or, that's
Oh,
part of
yeah, yeah.
training, or is it more like heuristics? If your problem looks like this, then your parameters should look like that.
Oh, yeah. So the optimizer I'm referring here is more like a gradient descent and Adam
Ah,
gradient
okay.
decay.
Got it.
Yeah,
Got it.
these kind of optimizers.
Got it. So not specifically the hyperparameter
Not,
type
not
of
that. Yeah,
optimization.
not that. Yeah, yeah.
Got it.
That is, I would say, another direction we are looking at. That is, for example, how to use common knowledge of this hyperparameter tuning from different domain to extract patterns, so we can more efficiently tune another workflow in a different domain. This hyperparameter technology, that's also, I would say, at the early stage of exploring.
Okay. But at the lower level, is this work on the optimizer, is that, do you think of that as kind of basic research trying to come up with a next generation optimizer, or is it more structurally something about the types of problems you're solving creates an opportunity to specialize the optimizer for those problems?
It is currently it is more research oriented
Okay.
for this direction. Yeah.
Okay. Awesome. Awesome. Well, Huiji, thanks so much for taking the time to share a bit about what you are up to.
Thank you, Sam. Yeah, it's a great pleasure to be here.
Awesome. Thank you.
Thank you.